Good evening again to today's online Zoom teaching. I'm Ing.Momoh Kenie. In case you have any comment, you want to make any contribution to any of the videos, you can do that via WhatsApp on 076-627-336. Yesterday, we went as far as combustion reaction. Today, we are going to look at the other reaction that saturated compound undergo. There are reactions that are only common to saturated compounds. And one of such reactions is substitution reaction. One of the reactions that is only common to the saturated compound is substitution reaction. Substitution reaction. Now, what do we call substitution reaction? Substitution reaction is a reaction in which one molecule takes the place of another molecule, or one element takes the place of another element. That reaction is known as substitution reaction. So if we are defining substitution reaction that way, there are specific conditions that must be present for substitution reaction to occur. If those conditions are not present, there will be no substitution reaction. One of such conditions is diffuse light. That for substitution reaction to occur, light must be diffused. There must be diffused light. The place will not be too bright, the place will not be too dark for substitution reaction to occur. And then substitution reaction occurs when with halogens. Substitution reaction occurs with halogens. Halogens are elements that are in group 7. These are group 7 elements. Example of halogens are chlorine, we have iodine, we have bromine, etc., etc. Now, when you take any one of the elements here and you do substitution reaction with that element, if you use chlorine, the last product that is formed will be HCl. If you use fluorine, the last product that will be formed is HF. If you use iodine, the last product becomes HI. If you use bromine, the last product becomes HBr, so that you cannot put the feet in cold water for the rest of the night to labor on them. Now, we are going to use any one of the elements here to write the substitution reaction. In the exam, you will be asked to write the reaction with this. Maybe what you will do is to write reaction with chlorine. In the exam, they will now tell you to write reaction with HI. They will tell you to write reaction with HF. So look at the format that I am using. Whatever format that I use with any of the elements will be the same format that we use to write substitution reaction with the remaining element. We now move to that. Now, if you want to write substitution reaction with chlorine, let us say we want to write the first member is CH4. Yesterday that was methane. We want to write substitution reaction with that, we say plus chlorine. I have just decided to use chlorine atom here. If that is chlorine as one of the halogens. So if that is the case, last product that is formed, the last product that is formed since it is chlorine that I have used becomes HCl. I now do the addition. I have one carbon here. I have not written any carbon here. This is C. This one is Cl. So I have not written any carbon here. That means I still have this carbon is transferred. I still have it. I have 4 hydrogen atoms here. I have transferred 1 here. That means I have 3 remaining hydrogens. I have 3 remaining hydrogens. Now I have 2 chlorine atoms, but I have written 1 chlorine atom. That means 1 chlorine atom is left. That is one of the products that I will get. Now I will take whatever I have produced at this point and do the reaction again. What I have here is CH3Cl and the CH3Cl. I will continue to add chlorine to it. When I add chlorine to that, all the time, anytime you add chlorine, you are going to have HCl. We'll do the addition again. The carbon is here. I still maintain the carbon here. Nothing has changed. That carbon is still constant. I have 3 hydrogen atoms. I have written 1 here. That means I have 2 hydrogen atoms left. I have 1 chlorine atom plus 2 chlorine atoms, 3 of them here, but 1 is already here. That means 2 chlorine atoms left. After that, we take the product that we have got at this point. We bring that here. We have CH2, Cl2. We add chlorine to it. When you add chlorine to any of these, the last product becomes HCl. Now you do the addition. The carbon is still maintained. Now we have 2 hydrogen atoms here. 1 is here. That means since we have 2 hydrogen atoms, I have written 1 here. 1 is left. 1 hydrogen atom is left. We have 2 plus 2, 4 chlorine atoms on the left. But 1 is already here. That means 3 more chlorine atoms. The product that I have got here, I will transfer it here. I have CHCl3. I still add chlorine to that. It's giving me HCl as last product. Now I do the addition. The carbon is here. I have 1 hydrogen atom. The hydrogen atom is transferred at this point. Now what I have there is no more hydrogen because that hydrogen is transferred. I have 3 here plus 2. 3 plus 2 chlorine atoms will be a total of 5 chlorine atoms. 3 plus 2 is 5, but I have written 1 here. Since I have written 1, I have 4 more. So chlorine atom will appear as 4. So substitution reaction, you continue to write the reaction in which until you reach at the point in which there is no more hydrogen. That is the last point for substitution reaction. You write until there is no more hydrogen present. So all these reactions are, the first part of the reaction becomes initiation reaction. This one becomes propagation reaction, propagation reaction, propagation reaction at that particular point. That is substitution reaction. And the light must be diffused. Maybe possibly use ultraviolet light or whatever, but the light must be diffused. And now in the exam, if you are given bromine here, you do the addition that I have done. If you are given fluorine, you use the formula that I gave, and then you do the addition. So you will not be able to waste the time, because if we have to write reactions on that, 2 years will not be enough to do that. Those are the skills now that you should do. You do the addition. Now here, you are not going to memorize any of these things. There is nobody that can even memorize it. You end up failing the exam. You use the formula that I have used. From the chemical properties, we go to physical properties. We go to physical properties of methane. Now try to understand this one. In the exam, somebody will ask you to write or to list 3 or 4 physical properties of methane, to be precise, or somebody will just say list 4 physical properties of alkane. So if I am now using methane as the first member, I am using methane, I will use it. I will say it is a colorless gas. It is a colorless gas. In the exam, if you are now asked to list 3 physical properties of alkane, you are not specifying again the alkane you want to discuss. They will just say in general term alkane. With that particular one, you say they are colorless. If you leave they are colorless and you write it is colorless, you are failing because of English language. It is not the chemistry that is failing you now, but English language. So since I am specifying here 1 member, I will say it is a colorless gas. It is also odorless. That means there is no odor for that. Like that. The simplest members are gases. That means the first 4 members. You say methane, ethane, propane, butane. Those are the first 4 members. They are all gases. From butane, that becomes a pentane onwards. Most of them are liquids, and the remaining becomes they continue in that particular trend. Again, the other physical properties you should know for these members is their boiling point will increase as the number of carbon atoms increases. That was explained yesterday. The more you get more carbon atoms, the more the boiling point increases. The more you get more carbon atoms, the more the melting point also increases. So we have the right to say it is the all of them now in general term that they are colorless. The first 4 members are colorless gases, they are odorless. Their melting point will increase as the number of carbon atoms increases. Their boiling point increases as the number of carbon atoms increases. Silver.